sharing the screen. And I think this is where I wanted to start today. We had looked last class at solving systems of equations using substitution. Today we're going to look at the elimination method. That first homework is not due for a while. It's not due till after Thanksgiving, but I would suggest that you try to get it done by next class, so that if you have questions, we can get them clarified. Exam 4, we will have one more in-class test that will be due, and by in-class, I mean not final exam, one more test that will be due on December 11th. We'll probably have a quiz on systems right after Thanksgiving.
Do we have a final exam in this class?
Yes, you do.
You do? Okay.
And that's what's up in the corner. Exam 4 is December 11th. The final exam is December 16th. In between the 11th and 16th, I think it's obvious that we will review. There is a practice problem set that we can go over together. You can work on your own and, as many times as you want. I do believe that the final exam is mostly made up of questions like what have been on all of the tests. It will be in my labs, as will test 4. And again, I will not give any credit if I do not see work. So
is it
go ahead.
Sorry, is it the same length as like a regular, or is it longer?
It'll be longer.
Okay.
It'll be a little bit longer than a regular test. And again, I asked that everybody did the test. Hopefully everybody sent me their work, submitted it in Blackboard, or sent it to me by email. I have to apologize. I haven't taken a close look to make sure all of the submissions in Blackboard went through. I will do that this afternoon. And if I don't have if I can't access your Blackboard submission, I'll send you an email. So any questions on any of that?
Can I talk to you after class?
Sure.
Thank you.
Sure. So then picking up from where we left off, we were looking at systems of 2 equations in 2 variables. We said that in order to solve, you could graph, you could use substitution, and today we're going to add the idea of elimination. Sometimes you see it called addition method, but I like to call it magic. In order to solve a system using this method, the first thing that you want to do is put both equations in ax plus by equals c form. You have your variables on one side, your constants on the other, and you want to make sure that your variables are in alphabetical order. Then what you're going to do is multiply both sides of one or both equations by a constant, so that the coefficients on one of the variables are opposites. Then we're going to use the addition property of equality to add the equations. If we did that right, you should now only have one equation with one variable. And so what we're going to do is we're going to solve the resulting equation for the remaining variable. And again, you have to be careful because once you get a solution, you get this false sense of confidence that you're done, but you're not. What we have to do next is back substitute. Into another equation. To find the remaining variable. And at this point, after you find that remaining variable, you'll have your ordered pair, both variables, and you'll feel like you've done an awful lot of work. And because you've done an awful lot of work, you want to make sure that you did it all right. So you're going to check the solution. You have to check it in both original equations. So that we have to do 2 checks. Let me know when you've got all of that down, and we'll look at a few examples. And after we look at a few examples, we'll broaden our horizons, yay, and do word problems, look at applications. Is everybody ready for an example?
I'm ready.
So for our example, let's solve the system. And let's say we have 2x minus 7y equals 2 and 3x plus y equals negative 20. Right now, does everybody see how my equations are already in that form? I know to use this method. I like to use this method when my equations look like this, where it's all kind of lined up nicely. The x's line up, the y's line up, the equal signs line up, and the constants line up. But right now, if I were to add these 2 equations, I would just get bigger coefficients. Nothing would cancel. So we need to do some multiplication here to allow us to eliminate a variable. If I wanted to get rid of the x's, the first one has a coefficient of 2. The second one has a coefficient of 3. And they both have the same sign. They're both positive. So I would think of multiplying this first equation by 3 and this second equation by negative 2. And then the x's would both have, one would have a coefficient of 6, the other negative 6, and I can add. I could also instead try to eliminate the y's. Now with this one, as I'm looking at the y's, does everybody see first of all, that they already have opposite signs. So this first one, I could multiply by 1. That's the coefficient on the other y, which basically has the net effect of leaving that equation alone. And the second one, I'm going to multiply both sides by 7. Again, we've got to use that multiplication property of equality, and whatever we do to one side, we've got to do to the other. And doing that, I get 21x plus 7y equals negative 140. And you might wonder, why did I do that? But now the equal signs are lined up, so I'm adding equals to equals, and I can add down. And when I add down, 2x plus 21x is 23x. But over here, negative 7y plus 7y is 0. And that's why I call it magic. We made the y's disappear. And then on the other side, when I add, I get negative 138. And now I have this equation in just x. 23x is equal to negative 138. And I can solve that for x. And I get x is equal to, I believe that's negative 6. Now we have to find y. To find y, we can go to either of the original equations or the one that we got by multiplying. I'm thinking I'm going to use that equation 3x plus y equals negative 20. And I'm going to substitute what I know, that x equals negative 6, which gives me 3 times negative 6 plus y equals negative 20, or negative 18 plus y equals negative 20. And when I add 18 to both sides, I get y equals negative 2. So I'm saying my solution is that x is negative 6 and y is negative 2. And I have to apologize. I'm writing a little big today, so I lost those original equations. So I'm going to have to recopy them. I'm going to check in 2x minus 7y equals 2. And I have to check in that 3x plus y equals negative 20. So first check 2 times negative 6 minus 7 times negative 2. Does that equal 2? Putting in my negative 6 for x and my negative 2 for y gives me negative 12 plus 14, which is 2. And it checks. And then in the other equation, 3 times for x, I'll put in my negative 6, plus for y, I'll put in my negative 2. Does that equal negative 20? Well, that's negative 18 plus negative 2, which is negative 20. And it checks. How's it look? Shall we try some more? Has everybody got it? Next example. Let's look at x plus 2y equals 2, and negative 4x plus 3y equals 25. Again, we have a choice.
I can learn to understand you much better.
Oh, we have a choice. We can eliminate the x, or we can eliminate the y. It's a matter of personal preference. What would you folks rather eliminate?
Would you make the x 4x
In
a
the
positive
first
4?
Beautiful. So let's leave the second equation alone. And let's take that first equation. And if I multiply one side by hello, I'm working ahead in my head. One side of the equation by 4, I have to multiply the other side of the equation by 4. So we've got that negative 4x plus 3y equals 25. And that becomes beautiful. 4x plus 8y equals 8. That's probably the easiest way with these, because now, since the x's are opposites, when I add down, they disappear. I'm left with 11y equals 33. And that's pretty easy to solve. We get y equals 3. And then we can go back to any of the equations with both variables to find x. I'm thinking that x plus 2y equals 2 is probably the easiest. So when I substitute the y equals 3, I get x plus 2 times 3 is 2, or x plus 6 is 2. And subtracting the 6, we get x equals negative 4. So our solution is negative 4, 3. And we need to check in both negative 4x plus 3y equals 25 and x plus 2y equals 2. So substituting negative 4 for x and 3 for y. Does that give me 25? 16 plus 9, yep. And in the other one, substituting in negative 4 for x and 3 for y, we get negative 4 plus 6, which is 2, and it checks. I'd like to do 4 more, and then I'd like to look at some word problems. Is everybody comfortable with this one? Or did I go too fast? Are we good?
I'm all right.
Okay, then next example. Let's look at 2x plus 3y equals negative 16 and 5x minus 10y equals 30. And do you notice we have no coefficients of 1, but my equations are in that standard form. Everything's lined up. And it's a matter of personal preference. What would you rather eliminate? The x's or the y's? Again, it's totally up to you guys. What would you rather eliminate? Anybody have a preference? X or Y? What do you guys want to do?
Do X.
Okay, so to eliminate X, where I have 2X plus 3Y equals negative 16, and 5X minus 10Y equals 30. Sometimes there are smaller numbers that we can use, but if all else fails, this one has a coefficient of 2, so we'll multiply the second equation by 2. This one has a coefficient of 5, so we'll multiply the first one by 5. What I do to one side, I have to do to the other. Right now, though, that would make them both 10. And we want one of them to be negative, so it's arbitrary. I'm going to multiply the second one by negative 2. Doing that multiplication, it's a little bit smaller. That first equation, be careful. Careless mistakes occur. Remember, you have to distribute and you have to multiply both sides. First equation becomes 10x plus 15y equals negative 80. Second equation, we have to distribute and multiply both sides. Doing that and watching our signs, because this time we're multiplying by a negative, we get negative 10x plus 20y equals negative 60. Is everybody comfortable to that point? Is everybody okay with the choice of the 5 and the negative 2? Hearing no complaints, I'm going to do my magic trick. When I add down, x disappears. Negative 10 plus 10 is 0. And I'm left with 35y equals negative 140. And so when I divide by 35, I get y equals negative 4. Now to check, we can go into either of the equations. And actually, we can even use these two equations that we got multiplying, or we can use one of the original equations. It doesn't really matter. And I said to check, I apologize. I meant to say to find x. I'm so sorry, to find x, to back substitute. So I don't know about you guys. I like smaller numbers. So I'm going to go back to the 2x plus 3y equals negative 16. That becomes 2x plus 3 times y is negative 4 equals negative 16. And I get 2x minus 12 equals negative 16. Adding my 12, 2x is negative 4. And so dividing x is negative 2. And so my solution, the x value is negative 2. The y value is negative 4. And again, we did a lot with this one, so let's make sure we do our check. First in 2x plus 3y equals negative 16. And then in 5x minus 10y equals 30. X again is negative 2. Y again is negative 4. So in the first equation, when I substitute negative 2 for x and negative 4 for y, I get negative 4 minus 12, which is negative 16, and it checks. In the other equation, I'm going to again substitute the negative 2 for x and the negative 4 for y, and see if that gives me 30. Well, that gives me negative 10 plus 40, which is 30. So it checks.
Can you pause for a minute so I can write this down?
Sure. Thank you for letting me know, because I get on a roll with these. Especially the magic part, I just think they're fun. So yell at me if I go too fast. Let me know when you got it.
I'm good now. Thank you.
Okay, great. So let's look at a couple more. This time, let's look at 4x minus 2y equals 2 and 6x minus 3y equals 3. What do you guys want to eliminate? The x or the y? Anybody have a preference? What are we getting rid of, x's or y's?
X's.
X's? So what should I multiply the first equation by, and what would you multiply the second equation by? You can multiply the first both sides by 6, second both sides by -4. Everybody all right with that executive decision? Okay, 24x minus 12y equals 12. And I get minus 24x plus 12y equals -12. And what happens when I add down here?
Both x and y would cancel.
Yeah, and wouldn't I end up with 0 equals 0? And so now everything's gone, and I'm asking, is that true? And is it true that 0 equals 0? Yes. And so it's an identity. And so those were one of the ones that we said was a dependent system. It has infinite solutions. It would be all the points that are what would be on the line. We could write it as a set builder notations, a set of ordered pairs x, y, such that we could put in either equation. 4x minus 2y equals 2. And that would be, if we looked and tried to graph it, these would turn out to be the same line. And so we had said that when we graphed them, if they were the same line, we would get infinite number solutions. For solving it algebraically, and we have no variables left, and the remaining statement is true, we'll have that infinite number of solutions. As opposed to, if I look at my next example, let's say I have 6x plus 2y equals 7, and y equals 2 minus 3x. Now with this one, it's up to you guys. Would you rather use substitution or elimination?
Doesn't matter which one.
No, doesn't matter. With-
Mm,
With this one, I'm almost thinking that substitution would be easiest because we've already got y all alone, right?
yeah.
So usually I use substitution if one equation is solved for one variable already. And so since y is all alone, I have 6x plus 2, and I'm going to replace y with what it's equal to. The other side of the equation will remain that 7. And y is equal to 2 minus 3x. So now when I simplify, I get 6x plus, I'm going to distribute here, 4 minus 6x equals 7. And holy crap, when I combine like terms, the x's cancel each other out and I get 4 equals 7. Double check. Make sure you did everything right. But because this is false, there are no variables left, and what I have is false, it means I have that inconsistent system. It means I have no solutions. They would have turned out to be parallel lines. And so I know we talked about those possibilities when we looked at graphing lines last class, and I kind of alluded to the fact that solving algebraically, you'll know they're dependent if you get an identity, something that's always true. And an identity would be my variables are gone, and I get that a number is equal to itself. As opposed to if I get a false statement, all my variables are gone, and I'm saying that two totally different numbers are equal to each other. That's going to be an example of those inconsistent systems where you have no solution. All right? And so let's look at another. Has everybody got this one down? If so,
Yeah, I'm good.
next example, let's say I have x over 4 minus y over 4 equals -1, and x plus 3y equals -12. What do you think about this one? Is there anybody else who kind of went, ew, fractions? If you have an equation like that contains fractions, does everybody remember we can clear the fractions if we multiply both sides by the least common denominator of all the fractions. And so before I do anything else, I would look at that equation, x over 4 minus y over 4 equals -1, and I'd actually put that -1 over 1. And does everybody see that here the least common denominator would be 4? So I'm going to multiply both sides by 4. On the left, I'd have to distribute. And 4 over 1 times x over 4 would leave me with 1x. 4 over 1 times y over 4 would leave me with 1y. And on the other side, I have to remember to also multiply by that same number to get -4. And so now doesn't my system look a lot better? With this system, you could use substitution or elimination. It's a matter of personal preference. My preference here, because everything lines up so nicely, would be to use elimination. And here, to use elimination, I would probably try to get rid of the x's, but does everybody notice right now the two x's are exactly the same? And I don't want them exactly the same. I want them opposites. So I would multiply one equation by -1. And again, whatever you do to one side, you've got to do to the other. So that first equation, let's keep that as x minus y equals -4. And that second equation, when I multiply by -1, remember you have to distribute and do both sides. I get -x minus 3y equals 12. Now, when I add it down, I'm lining up the equal signs. If these are equal and these are equal, their sum should be equal. And notice because the x's are opposites, they would end to 0 that we don't need to show, or they magically disappear. And I get -4y equals, what would that be, 8? And then dividing by -4, I'd get y equals -2. And again, we can check in any of the equations. I'm sorry, not check, back substitute. I'm misspeaking again. I'm so sorry. I'm thinking that x minus y equals -4 looks like it would be the easiest. So I get x minus -2 equals -4, or x plus 2 equals -4. Or subtracting, I'd get x equals -6, giving me the solution -6, -2. And now let's check. And so, what was that first equation? I lost it. X over 4 minus y over 4 equals -1. So let's see, x is -6 over 4 minus y is -2 over 4. Does that equal -1? Well, I've got that common denominator. Let's see, adding the numerators, -6 minus -2, the double negative would turn it out to be positive, giving me -4 over 4, or -1. And then my other equation, x minus y equals -4, -6 minus -2 would be -6 plus 2 is -4. And so it also checks. So don't be afraid if you have fractional coefficients. You can, if you want, clear the fractions before you begin by multiplying both sides by that common denominator. Questions? If not, next place we're going are applications. Again, those applications are word problems. We have to read carefully. We have to define our variables. And with these to define our variables, we'll have two variables. And so then we'll have to write two equations. Sometimes a picture's worth 1,000 words. So sometimes a diagram helps. Sometimes a table helps. And so what I did was I downloaded some problems from the digital textbook. By the end, I got to the point where I can probably just download one question to a page, but I started out a little rough, so I have to apologize. There'll be a couple of questions on the first couple pages. But if everybody's got that down, let's look at some examples. And so here on the first page, I just want to look at this first problem, 77. It says, at the North Campus of a performing arts school, 10% of the students are music majors. At the South Campus, 90% of the students are music majors. The campuses are merged into one campus. If 42% of the 1,000 students at the new campus are music majors, how many students did each of the North and South campuses have before they merge? Well, is everybody all right with this problem? We're looking for two things. We're looking for the students at the South Campus. And we're looking for the number of students at the North Campus. And so is everybody all right if I have X be the students at the first campus and Y be the students at the second campus? Now we've got to write a couple of equations. I think the easiest equation is if I know that there were 1,000 students when they merged, does everybody see that one equation will be X plus Y equals 1,000? But I think we have to do a little bit more work for our second equation. At the North Campus, 10% are music majors. So that would be, I have no idea what happened there. That would be 0.1Y, 10% are music. And then at the other one, 90% are music. 90% is 0.90 or 0.9. So 90% of the people at the South are music majors. And we know that the total music is 42%, 0.42 of the total of the 1,000. And so that would give me 420. And so my second equation would be the music majors at one plus the music majors at the other will combine to 420. Does that make sense? Any questions? If not, then this is the system that we have to solve. To solve that system, we can eliminate x or we can eliminate y. And I'm just thinking this second equation, if I were to multiply by -10, multiplying by 10 would move the decimal one place. And so if I take -10 times 0.9x plus 0.1y equals 420, I'd also have to multiply by -10. I'd get -9x minus y equals -4,200. The other equation is x plus y equals 1,000. And so now if I add, I get -8x, the y's would be eliminated, and I get -3,200. When I divide by -8, I get x is 400. So I'd have 400 students. And what was x? South? Oh, then if there's a total of 1,000 students, 1,000 minus 400 would give me 600 at north. And then to check, 90% of the 400 at south would be 360 music majors. 10% of the 600 at north would give me 60 music majors, which combines to 420 music majors. And so I think I did something right. What do you think? That one all right?
Yeah.
If so, let's look at another problem on another page. This time I want to look at, oh, I don't care, 79 or 80. Would you rather look at hotel rooms or restaurants?
Hotel rooms.
Okay. So then let's look at 79. '79 says hotel has 200 rooms. Those with kitchen facilities rent for $100 a night, and those without kitchen facilities rent for $80 a night. On a night when the hotel was completely occupied, The revenue was $17,000. How many of each type of room does the hotel have? So what are we looking for? I think we're looking for the number of rooms with kitchens and the number of rooms without kitchens. So does it make sense if I let K equal the number with the kitchen? And I let W equal the number without. I'm getting real creative here in my choice of letters, guys. Now, if there's a total of 200 rooms, what would my first equation look like? Anybody?
Wait, so K is the number with kitchens. So kitchens with the night, or that's $100 per night. So K, I don't know how to set it up.
Okay. Well, you're thinking way beyond where I want to think. There's a total
Oh,
of
okay.
200 rooms. So would K plus W have to equal 200?
Yeah.
Is that like that's the easier equation? But I love where you were going with that other part. If the kitchen facilities are 100 a night, wouldn't they earn 100K?
Yeah.
And the other ones are $80 a night, so wouldn't that be 80W?
ADW.
And the total
Then
amount,
equals 17,000.
beautiful, I love it. You're on the right track, great. Now we could substitute, or we could eliminate. Doesn't matter to me. Which one do you guys like better?
Substitute.
Okay, so to substitute, do you want to solve for W or do you want to solve for K?
Doesn't really matter, does it?
No, it doesn't. Which letter do you want it?
Okay.
Okay, so if K plus W equals 200, to use substitution, we can subtract W from both sides. And we get K equals 200 minus W. With me so far?
Yep.
And so we're going to replace K. 100K plus 80W equals 17,000. But K we're going to replace with 200 minus W, what it's equal to. And I know it's childish, but before I do that substitution step, I always write the equation and I just leave a blank for the variable I'm going to replace. And then I go back and fill in what it's equal to. Distributing, we'd have 20,000 minus 100W plus 80W equals 17,000.
And we can add the 100W and the 80W.
Right. One's positive and one's negative, though. So that's going to give us minus 20W.
20.
17,000.
And then subtract. Do you
Yeah.
subtract the 20,000?
Yep, that's what I would do. So we get negative 20W equals negative 3,000. Divide by negative 20. And we get W is 150. Somebody check me on that.
Yeah.
And so that tells me there's 150 without.
Oh, wasn't that one with?
No.
Oh, no, we solved for W. Okay,
Yeah.
okay.
And then if there's total of 200, we
50.
have 50 with a kitchen. And then let's see, 150 rooms and, oh Lord, I lost it, $80 a night is 12,000. And 50 rooms at $100 a night is 5,000. And so, yeah, they make 17,000 a night and it checks.
Oh, that's the check. Okay.
Because notice when I do the check, I'm not substituting back into my equations. I'm looking at what the problem says. Because I could have written the wrong equations. And if I just substitute it back in to the wrong equations, it would have checked, but it might not have been right. Do you know what I'm saying? So always check in the words. Of the situation. And I think there's two other types of problems that you're going to see on the homework. And hopefully we'll have enough time to look at the both of them. Next one that I'd like to look at, is everybody done with this one?
Yeah.
Next one that I'd like to look at is number 81. Let's try that again. Which is the one with the table. And I'm going to use this one because they've got that table started us for it already. It's considered a rate problem. And with a rate problem, a table can help. And what we have to realize is that rate times time equals distance. Is that relationship something that everybody is familiar with? If I was driving in Pennsylvania, the speed limit was 70. If I was driving 70 miles an hour for 2 hours, wouldn't I have gone 70 times 2 or 140 miles? And so rate times time equals distance. So this says that a crew rows with the current and it goes 16 miles in 2 hours. But when you're going with the current, you go faster. Has anybody ever like done a kayak or a rowboat or something? And when you're going with the current, you fly, you go faster. The crew goes against the current. It goes 8 miles in 2 hours. When you're going into the current, it slows you down. And it's because when you're going with the current, it pushes you. You add that to your speed. And when you're going into the current, it slows you down. You subtract the current from your speed. So here they're setting it up for us already. X is the cruise rate in still water, and Y is the current. When we're going with the current, we add the rate, we're going faster, so we get X plus Y. And rate times time equals distance. When we're going against the current, we subtract the current from our speed. It slows us down. And again, rate times time equals distance. So my first equation, rate X plus Y times time 2 equals 16 would take me to 2x plus 2y equals 16. My second equation, when I'm going slower, the current slows me down, I subtract it. x minus y times 2 is 8. And that gives me 2x minus 2y equals 8. I'll ask at the end of class for late folks. So just remind me, Mary, I think somebody else also came in late. I forget whom though. Now, does everybody, I think the way this one's set up, I would probably use elimination because my y is already opposites. So adding down, I get 4x equals 24 and x equals 6. So they row at 6 miles per hour. And then substituting in any of our equations, 6 plus y times 2 equals 16. 12 plus 2y equals 16. Subtracting the 12, 2y would be 4. So the current is dividing by 2 miles per hour. So with the current, we'd be going 6 plus 2, or 8 miles per hour. And against, we could be going 6 minus 2, or 4 miles per hour. So in still water, we're rowing 6 miles per hour, and the current is 2 miles per hour. And do you see how putting the information in the table helps set the problem up? Let's see. We've got 5 minutes, actually 6. So let's set up one more. And I really like this problem, but the next ones are closer to what you see on the homework. So, oh, should I do that? Do you guys want one extra credit problem?
On the homework?
Yeah. What would we count the extra credit towards? We could kind of backtrack a little bit and count it as extra credit towards the test, I guess. Should we do it or no?
Yeah.
Yes,
put
please.
Extra credit on the top.
Okay, so this question is extra credit. It'll count as 5 points towards the test. And don't worry about the figure in the book. Let's say that you have to email it to me by what time? End of the day. Tomorrow. All right?
Okay.
Okay. Now this one. let's look at, I guess, 61 because it's the first one and we're running out of time. Okay, we want a cost function, a revenue function, and the break-even point. It says a company that manufactures small canoes has a fixed cost of $18,000 and it costs $20 for each canoe. So the cost is $18,000 plus, they're saying X is the number of canoes. So that would be 20 times the number of canoes. The revenue function is the money that they take in, and the money that they make is $80 for each canoe. And for the break-even point, we want those two to be equal. And then from there, hopefully everybody's capable of solving on their own. General idea of that one, all right?
Yep.
Okay. Then I'm going to stop sharing. I'm going to stop recording.